All right, now let's take a look at some examples that are not word problems and just sort of fine-tune some of the algebraic details. Here's the first one. Find all possible solutions, rounded to 2 decimal places, for the sine of theta equals 0.55, where theta is in radians. All right, so I'm going to take the inverse of each side. So I'm going to write sine inverse of the sine of theta is equal to sine inverse of 0.55. Now, when I put that into my calculator, inverse sine of 0.55, I got approximately 0.58. I actually got 0.5823642379, but rounded to 2 decimal places, that would be 0.58. Now, that makes sense to me because if I think about the unit circle, here's the unit circle, that is an angle measure that is producing a sine of 0.55. Now, that's a positive number, and we know that we see positive sine values in quadrant 1 and also in quadrant 2. In fact, 0.55 for a sine is going to be about maybe right there, right? Remember this piece right here, the height, that is the 0.55, and here would be a height of 0.5, so that's why I put the 55 just a little bit higher than that. So this angle measure from the positive x-axis to that terminal side, that is the 0.58. Now, we learned on that application problem that we can expect that there is another angle that is in quadrant 2 that, let's see if I can make that look good, that has the same reference angle, right? Has the same reference angle. So this piece right here is that 0.58. That is the reference angle. So what we want to know is what is the angle from the positive x-axis all the way to that terminal side. And if you recall, I think you can see it here, that if halfway around is pi, then all I have to do to figure out that quadrant 2 angle is go all the way around to pi and then back out that reference angle. So we're going to say that the other solution is that theta is equal to pi minus that 0.58. Now, I've talked about this before. When I put this into my calculator, I'm not writing or typing in pi minus 0.58. I'm actually taking the full solution that I got before and putting that in. So I'm going to put in pi minus 0.5823642379, and when I do that, I got approximately, I think I got 2.56. So this said to find all possible solutions. The period of this function is 2 pi. So I'm going to add to this 0.58. I'm going to write plus 2 pi k. For the 2.56, I'm going to write plus 2 pi k. And I'm going to say in both of these situations that k is some integer. You always want to, if you're going to introduce a variable like k, you want to make sure that you define it. So our definition of k is that it is an integer value. And again, all that means is that if I were to go to, say, the 0.58 and I were to add 2 pi, that would get me another solution. If I add 2 pi again, that gets me another solution. Same thing for the second quadrant. I could add 2 pi. I could add 2 pi, and I know that this is getting messy, but then I could also go the opposite direction, couldn't I? Instead of going counterclockwise, I could go clockwise, and going clockwise is what gets me those negative k values. Now, for situations like part B, where the output is an angle measure that I have memorized, I don't think I need my calculator. It says find all possible exact solutions for when the sine of an angle t is equal to 1/2. All right, well, let's see. And let me just erase this mess that I have over here. Let me just erase all of that. Hopefully you have your unit circle memorized, and you have memorized that we are at an angle measure of, I think it's pi over 6, around pi over 6. At pi over 6, we're at the ordered pair, square root of 3 over 2, comma 1/2. So we're talking about the sine, and so the sine is going to be 1/2 when the angle is pi over 6. We also see that in quadrant 2 at 5 pi over 6. Now, do I have to do that business with the pi minus? I don't have to, because I have this is one of our special angles, and I have it memorized. But just as a side note here, do note that if I had forgotten that, I could take pi minus that first quadrant answer, and I would still get 5 pi over 6. So it does work as a backup that this is going to happen. Okay, I want all solutions, so I'm going to say that the solutions are t equals pi over 6 plus 2 pi k, and also t equals 5 pi over 6 plus 2 pi k. In both cases, the k is an integer. Now, I talked about the pi minus, whatever the calculator gave you on part A. I just talked about it again in part B. Let me just generalize that really quickly before we go on to part C. The solutions to a sine equation, such as y equals the sine of x, are x equals some theta value. Now, theta is the value that your calculator gave you. And we know that that for sine is going to be between pi over 2 and negative pi over 2. But then, outside of that, there's another solution. And that solution comes from taking pi and minusing theta, and then adding plus 2 pi k. Again, that is over the interval where the calculator is giving you an answer for theta only in quadrant 1 or 4. And again, for k being an integer, we're talking about the values of k between negative infinity to positive infinity. All right, let's finish this out by looking at part C. Sine of theta equals negative square root of 2 over 2. Now, if I have that memorized, then I know that the angle measure that produces a sine of negative square root of 2 over 2 is an angle measure of 5 pi over 4 and also 7 pi over 4. Now, if I had put that into my calculator, sine inverse of negative square root of 2 over 2, it would have given me the solution of negative pi over 4. And that is because of this limitation. Now, the reason why I'm not going to use the negative pi over 4 is because I looked ahead and saw that this particular problem only wants the angle measures that are between 0 and 2 pi. So what I would have had to do if I wasn't, thinking clearly about that is I would have had to add plus 2 pi k, k where k is equal to 1. And that would have given me the solution that I sort of knew by just having it memorized. So the moral of the story here is if you have your angles memorized and we're dealing with some of our special angles, then you don't need to worry about this rule here, either one of these rules. You can just say, okay, on the unit circle between 0 and 2 pi, where do I expect to see the sine having a negative output? And I know that that's going to happen here, and I know that that's going to happen here. That's where that sine is some negative value, and in this case that value is negative square root of 2 over 2. And what is this angle? And what is this angle? We know just by memorizing that that angle is 5 pi over 4 and 7 pi over 4. So this particular problem could be done really quickly if I have it memorized. Now, one last thing that I'm going to say here is that when you are asked for a solution between a closed interval, so in this case it's between 0 and 2 pi, Yes, theta is 5 pi over 4. Yes, theta is 7 pi over 4. I'm going to write that formally as a solution set where I use set notation. These are little squiggly set notation. And we'll write 5 pi over 4 and 7 pi over 4 and then close off that set notation. That is the formal way that you should approach writing solution sets.